So we will talk about the entity relationship modeling. So when we do the entity relationship modeling, we will create an entity relationship diagram. So modeling has been around forever. We can do modeling when we design anything. You design a car or you design whatever, you can do modeling. And usually people do modeling whenever people design something. In the context of designing a database, we do this specific type of modeling, entity relationship modeling, and then we create an ERD to describe our design. So when we create a diagram, we need to have a way to describe the diagram, right? It's just like when you write a paper, you need to have a way to describe your thoughts. So are you going to use English or are you going to use French or some other language, right? You need to have a way to describe your thoughts. So when we create an ERD, we need to have a way to describe our design as well. There are two different ways, two different notations. Unified Modeling Language, UML, is getting more and more popular. The closed-foot notation is the dominant notation used in the industry. So in our course, we will cover both UML and the closed-foot. But on your project, we are going to use the closed-foot notation. And we're going to go over the details about each in a little bit. To do modeling, when we design a database, there are three major topics we need to be familiar with: entities, attributes, and relationships. Entities are the real world object, real world things. If we develop a library management system, we design a library management database, then our entities would be users, right? Libraries, books. So those are the real world things that we will work with for a library management system. We also need to know the details about each entity. For example, for a user, we want to know the user's name, right? Maybe the phone number, email, and some other details about a user. For books, we want to know the author of the book, ISBN, publisher, and so on and so forth, right? And the details about an entity are attributes. We also need to know how entities are related to each other. For example, use our library management system. We know a library has users, right? So there is a relationship between the library and the user entities. A user checks out books. So there's a relationship between the user and the book entities. So relationships tie entities together. In an entity relationship diagram, all entities must be connected. So keep this in mind when you work on your project database. And we are going to introduce keys. I think up to now, many of us have already worked with keys as long as we have worked with data, right? And there are three types of important keys we are introducing here: candidate, primary, and foreign. So these three types of keys are commonly used whenever we work with data. So a candidate key is a key that can uniquely identify and retrieve, look up a tuple, each and every tuple in an entity. So in an entity, we have many tuples. We need a way to uniquely identify each. Then a candidate key can do that. For a candidate key, we can have just one attribute. If we have just one attribute for a candidate key, we say it's a simple key. If we have a combination of attributes which we use as a key, we say it's a composite. It's a composite key. Okay, I think I'm getting some requests about transcription, so that's fine. So I have enabled transcription, okay? And based on my experience, this system works pretty well, but because we are talking about some technology terms, so just pay attention to sometimes technology terms might not be interpreted or translated properly. Just keep this in mind, or transcribed properly. So we talked about the difference between a simple key and a composite key. And we learned a candidate key can uniquely identify and retrieve each and every tuple stored in an entity, right? I put one example here. Yeah, is there a question?
Yeah. I just want to ask, because I searched on the explanation of candidate key. It said if the key has no other features, it could be candidate. So can we understand that every, for example, every tuples, as you said, can be a candidate key?
So I feel the question is about what qualifies as a candidate key, right?
Yeah,
Was that
exactly.
your question? So a candidate key, as long as an attribute or a combination of attributes. So a key could be just a single attribute, could be a combination of attributes, right? So as long as we have one attribute or a combination of several attributes, which can uniquely identify and retrieve each and every tuple in an entity, then that qualifies as a candidate key. Did it make sense?
Yeah, so we can choose any candidate key as our primary key, right?
Right, yeah, we're getting there, okay? So a primary key is one of the candidate keys that we have chosen to function as the primary key of an entity. And each entity can have only one primary key. Just keep this in mind. And another type of keys is foreign key. In a relational database, even in a NoSQL database, we need to relate data stored at different places to each other. And we would use, generally speaking, the primary key of the parent entity to relate to the foreign key of a child entity. So in other words, we use the primary key foreign key pair to relate a parent entity to a child entity or vice versa. Okay. So these are the three different types of keys, and I put together one example here. A very simple employee entity. In this entity, we have several attributes: employee ID, SS number, that's the social security number, last name, first name, and the middle name. And we can see there are three ways to uniquely identify each and every tuple in this employee entity, right? We can use employee ID or SS number. So these two are good enough to uniquely identify each and every tuple in an entity. We could also use the combination of names, last name, first name, and the middle name. The combination of names can uniquely identify each and every employee stored in this employee entity as well. So simply speaking, we have three candidate keys for this entity, this employee entity. And most likely, we will select employee ID as the primary key. That's what the industry is doing because of the privacy. We try not to use SS number whenever it's possible. So employee ID sounds like and has always been the preference to function as the primary key of this employee entity or entity similar to this. So once we have selected employee ID as the primary key of this entity, then the other two candidate keys, that's SS number and the combination of names, those will become just a key or alternate keys. Okay, it's just a new term, alternate key. So the other two candidate keys became alternate keys. We also introduced a new concept here, a surrogate key versus natural key. You look at employee ID and SS number, those are generated by the database. We call those keys artificial keys or machine-generated keys. They don't carry any business meaning. They are consistent, they are efficient, but they do not carry any business meaning. You look at an employee ID, you look at a social security number, you don't know which person you are looking at, right? So we call machine-generated keys or artificial keys a surrogate key. Keep this in mind. A surrogate key is commonly used in the industry. They are efficient, they maintain data consistency, but they do not carry any business meaning. On the other hand, we have a natural key. The natural key in our example is the combination of names, the combination of first name, last name, and the middle name. You look at Simon W1, you know the person. You maybe know, I hope you know what you are looking at, right? So a natural key carries some business meaning. Ideally, we would use a natural key for all entities as the primary key, right? But unfortunately, a natural key does not perform well because we may have a very long natural key. A long primary key does not perform well. And also a long character string, like the combination of names, may cause data consistent issues, typos, right? So make sure we keep this in mind. There are two types of keys, surrogate key versus natural key. And this is one way to classify keys. And very often, a surrogate key is used in the industry for an entity. So we will continue on. When you read your Carnegie and Beck book, you will read about these three types of data integrity: domain integrity, entity integrity, as well as referential integrity. Domain integrity is about the column data integrity. Column data integrity is vertical, right? Column data integrity. We use SQL data types or database data types and SQL check constraints to enforce domain integrity. We are going to talk about data types and the check constraints a lot after a few weeks. The second type of data integrity is entity integrity. Entity integrity is horizontal. It's about the raw data integrity. We use primary key to enforce entity integrity. The third type of data integrity is referential integrity. There are two types of referential integrity. The first type is the referential integrity between two entities. Think about our library management system, right? Whenever you check out a book in the checkout entity, you will specify the user ID. And you want to make sure that user ID is a good user ID, right? Because you want your book back. So that's the so-called referential integrity between two entities, two different entities. The second type of the referential integrity is the referential integrity between different tuples in the same entity. Think about an employee entity. For an employee, we may have a manager ID attribute, right? An employee has a manager. Managers are also employees. So whenever you enter the manager ID for an employee, you want to look up that manager ID in the employee attribute, in the employee column, to make sure it's a good employee ID. Manager IDs and the employee manager IDs and the employee IDs are the same because managers are also employees, right? And that's the referential integrity between different tuples in the same entity. And keep in mind, we're just talking about the data, right? Because we're talking about the data stored in attributes or stored in columns. In the industry, when the database is implemented, we understand this data integrity is related to business rules. Business rules are so important. We want to enforce the business rules. And you have the data stored in your database. Your application is running. Your users are using tools to work with the data. You want to ensure this integrity and the business rules are enforced, right? But now we're just talking about the data. You have the data in the database, and if your users, your applications just work with the data the way it is now, the performance will not be good. Because to enforce these types of data integrity, the database management system will need to do a table scan. We'll need to do very thorough search in each column or in each table to enforce the data integrity. Therefore, when the database is implemented in the industry, before the application or the users can use the data, you must do indexing as well. You do indexing, okay? You create indexes based on the key columns, the primary key, the foreign key, and some columns that you will query a lot. And that's very, very important. That's the reason why indexing is so important. And indexing itself is a specialty. It's important for all types of databases, relational as well as NoSQL. Just keep this in mind. We have a very simple example, two entities, right? Project entity and employees entity. They are related to one another using a common column. The common column is project ID. This is how we relate entities to each other in a relational data model. Believe or not, this is also how we relate data within a NoSQL database. So that's the reason why we want to study the relational data model, relational databases first, because the relational data model and the relational databases are a lot more rigorous than NoSQL databases. If we know relational databases, relational data model, well, then a lot of what we have learned can be easily applied to NoSQL databases, because NoSQL databases use the same technologies, the same concepts, the same theories as relational databases. They just do not use all of them. Okay, this one is kind of important. I took this one from your book, and we're going to talk about multiplicity. Multiplicity is about how we configure relationship. Remember, in a model, we have entities, we have attributes, we have relationships, right? Multiplicity is about how we configure relationships. Multiplicity is what we use to enforce, to implement the business rules. And business rules, business requirements are always our #1 priority, right? So very, very important. And multiplicity can be broken up into two parts, two components, cardinality as well as participation. Look at the definition first. Cardinality is how many tuples from each entity can participate in the relationship. Participation is whether a tuple from an entity is required, must participate in the relationship. We have a very simple example here, an ERD with just two entities, staff and branch. And this is UML, okay? We're going to go over the notations in a lot more details later, but I just want to share some info with the class. So this is an ERD, very simple ERD based on UML. We have two entities, staff and branch, entity name, primary key, entity name, primary key. There is a relationship between them, and this relationship is named managers, and there's a direction going from staff to branch, okay? Now, let's talk about cardinality and participation. Again, cardinality is about how many tuples from each entity can participate in the relationship, right? Those things are specified in the business rules. So you can read your Carnegie and Beck book to read all details about the business rules related to this diagram. But in summary, the business rules say one branch can have only one manager. Every branch must have a manager. One staff member can manage at most one branch. Not all staff members are a manager. Okay, so I summarized the business rules for you, and look at cardinality. Right? One branch is managed by one member of staff, and one branch can have only one manager, and one member of a staff can manage just one branch. So 1 and 1 for cardinality. Okay, so a staff member can be a manager for just one branch. A branch can have just one manager. The cardinality on each side is 1 and 1. So 1 and 1. Now, let's talk about participation. Participation is about whether a tuple from an entity must participate in the relationship, right? So we go from staff to branch. Not all staff members are a manager. Therefore, we see 0. 0 indicates optional. So the participation for staff members is optional. We go from staff, I'm sorry, we go the other way, right? We go from branch to staff. Then the participation is 1. Every branch must have a manager. 1 indicates mandatory. So for participation, 1 is mandatory, 0 is optional. For cardinality, we just specify the appropriate number, right? In our example, it's 1 on each side. And with UML, you will see these 2 numbers. Generally speaking, the first number indicates the participation. It's either 1 or 0. The second number is the maximum cardinality. In our example, that's 1. Any question? So when you read your Carnegie and Blake book, there are pages describing this. But if you have followed our discussion for the last maybe 2-3 minutes, then your reading assignment will be much easier. Okay, so let's continue on. We are going to look at the symbols of the UML notation. An entity is represented by a rectangle. If we just list entities without any other details, we would put the entity name within the rectangle. We can include more details. In the middle example, we have the entity name on top, and then we have the primary key right under the entity name, right? We can have even more details. In this example, we have the entity name, and then we have the primary key, and then we have the alternate keys, right? Remember, alternate keys are the candidate keys, which we didn't choose as the primary key. And then we may have a composite attribute. An example of a composite attribute is the address, right? And the components of a composite attributes are listed below and indented to the right. For example, street number, apartment, city, state, country, right? We also have derived attribute. So if you have a derived attribute, you would start it with a slash. A derived attribute is a calculated attribute. It's something that does not exist in the database directly. Instead, that's something we can calculate. We can calculate from other things. For example, you could store date of birth in your database, but you can calculate the age, right? The age of a person by using the person's date of birth. Then the age would be a derived or a calculated attribute. And we could have multi-valued attributes. Multi-valued attributes, there are examples of that. A good example is phone numbers, right? If your business rule says a person can provide up to 5 phone numbers, but must provide at least 1, right? At least 1, but can have as many as 5. Then you would put 1 and 5 here, and then you know, phone number 1 and so on and so forth. Okay, so those are multi-valued attributes. Relationships are represented by a line. With UML, there's just one type of line. It's always solid. A relationship can have a name. A relationship can have a direction as well, right? And for a relationship, we can specify values, minimum, maximum, minimum, maximum, right? Remember what we just went over? Minimum is, okay, so let's go back to that example here, right? I think one way to interpret this is participation and maximum cardinality, okay? You see multiplicity. The most common data relationships, the most common data relationship in the universe is binary. So a binary data relationship involves two entities. We could have some more complex data relationships. This example is of a ternary relationship. Okay, if we have a ternary relationship, we would use a diamond to indicate the relationship. If it's binary, then it's just a line. We have a lot to cover, so I will ask whether there are questions, but in the meantime, I want to make sure I'm efficient, okay? So let's talk about the closed foot notation. Remember, UML is becoming more and more popular, but closed foot notation is still the dominant notation used for database design. When you read your Carnegie and Beck book, I'm assuming you all have the current version, that's edition 6. Then the authors used the UML notation, UML notation, but in earlier editions, the authors used the closed foot notation, just for your reference. So with the closed foot notation, we still represent the entity as a rectangle. Okay, so entity, relationships are aligned. But with closed foot, there are two types of lines. For example, this one is dotted or dashed. Another type is solid. So we will talk about the difference between a dotted line and a solid line in a little bit. A relationship can have a name. And then participation, if participation is mandatory, we use a vertical bar. Cardinality is 1, then we would use another vertical bar. Mandatory, that's a vertical bar here. Many, that's the closed foot. Okay. And the primary key in the closed foot notation is an asterisk. But nowadays, it depends on what design tool you use. You may see different symbols. For example, a PK is a common one, okay? It's not always an asterisk. If you use MySQL Workbench, it's just a key symbol. So it depends on the design tool you use. But if you want to draw an ERD on a paper, you draw ERD on paper, on a piece of paper, then you would use an asterisk to indicate a primary key. Relationship can have a name. Many is the closed foot. Many is cardinality, right? One side, that's a vertical bar. Also cardinality. Mandatory, that's participation. If it's mandatory participation, it's a vertical bar. If it's optional, then it's a circle. Lastly, we want to talk about data modeling. Data modeling can also be called class modeling. So data modeling, object modeling, class modeling, they all mean the same thing because today we do object-oriented programming, right? We do object-oriented software development, and good data modeling, object modeling, class modeling can ensure our project will be delivered successfully and meet the business requirements. In the industry, you will see a job title, a type of job called data modeler, object modeler, or class modeler. A modeler must know the business. Okay, you must know your domain. If you are in telecom, you must know the telecom business. If you are in banking, you must know the banking business. You also need to have technical knowledge about the solution and the modeling, right? And I was a modeler with AT&T Wireless for a while, and we were developing software or applications to be used by our stores. So we had 2,000-3,000 stores at that time. And I was a modeler. I was also a software architect. So to do modeling, I had to have both the technical knowledge. I also had to know the telecom business, right? For example, if a customer gets a new phone, we need to know how the new phone can be provisioned, how the new phone can be activated, how the billing can be set up, right? So those are the things a modeler needs to know regarding database design and regarding software architect, how you develop applications to deliver, to meet the business requirements, right? And the applications and the systems are based on the databases, so they go together. Okay, so we went over modeling very quickly. Is there any question or any comment, please?
Yeah, Professor, I have a question about the lines that connected to entities. So yes, so it is dotted line. I watched your video and you said it is not identifying relationships. So
Right.
Could you explain more about that?
Yeah, please hold your question. We are going to talk about non-identifying versus identifying. Okay, hold your question just for a few minutes, because it's a specific topic. Would that be okay?
Yes.
Okay, and also thank you for asking that question. When I see these symbols, and it reminds me of emphasizing this to the class. You look at the UML, look at the UML notation. We have numbers, right? On each end, you have two numbers. One is for participation. The other is the maximum cardinality. But if you look at the crossfoot notation, we have, for example, on this end, we have this for participation, right? Vertical bar. And then we have this for cardinality. So we have symbols, we don't have numbers, okay? And also, for a relationship, there's a line. There are two ends of a line. On each end of the line, there are two symbols. So one is for participation, the other is for cardinality. Make sure we do not leave out any, okay? We need to have two. Even we use UML, you need to have two numbers. So a common negligence is to have just one. Any other question, please? Okay, so
Professor,
yeah.
On that crowfoot diagram, That means the first item, which is the whether bar or this multiplicity, is always for the cardinality, and other one is for the participation.
So it depends on how we look at that, right? For
Mhm.
example, you look at here, the first one is participation, right? Second
Okay.
one is cardinality. You look at here, first one is participation, second one is cardinality. So one way to say that is, I think you are right. The first one is participation, the second one is cardinality, or the one to the left, the one to the right. It depends on how you look at them, right?
Yeah. Got
Okay.
it. Thank you, sir.
Yeah, great question.
Professor, I have a question.
Sure.
It's about the third picture on the crossword notations. If we translate into UML notation, does the round means 0.1 if we
Yeah.
use UML?
One is for example, you look at this circle, right?
Yeah.
This circle is optional participation. In UML, that's 0.
Yeah. But UML has two
Two numbers.
on each side.
Wait.
So it means 0.1, right?
No, 0 could be 0, 1, or could be 0, 0, depending on the business rules.
Oh, okay. I don't know if any existence of 0.0.
For example, you can have two entities, right? One is patient, one is physicians,
Mhm.
and there is a relationship between patients and physicians.
Mhm.
You could have a physician, a doctor,
Mhm.
who doesn't have a patient yet, right?
Yeah.
Then there will be 0, 0, 0.
Oh. So no patient and no physician. So 0 to 0.
0, 0, and the 0 meaning optional participation, cardinality 0.
Okay.
Making sense?
I will try to.
So sort of. Okay,
Professor,
well, yeah, we'll look at some examples. It's going to becoming more and more clear. Okay,
Okay. Thank you.
sure.
That could be understood as a matrix, right? The relationship logic is OR, right? That is the matrix. As you said, that could be 0, 0 or 0, 1, or that could be, for example, I just means that the relationship is OR in logic, right?
Well, there are two sides of the line, right?
Yeah.
On one end, it's the parent entity. On the other hand, that's the child entity. On the parent entity's side, the maximum is 1.
Yeah.
Always 1, because otherwise you are going to get very confused. So we will look at a lot of examples. So when you see data, when you see examples, it's going to make a lot more sense, because for now, you just need to keep in mind a relationship connecting two entities, the parent entity and the child entity. On the parent entity side, the cardinality is 0 or 1. On the child entity side, okay, the cardinality could be many. That's the reason why we have crossword there. It's all about the business rules. So you can say, okay, on the parent entity side, there must be 1 or optional participation. So I think we're just playing what ifs, right? So look at the examples later, and then we can further talk about this. I think it's going to make a lot more sense. Any other question, please? Okay, so I
Yes,
will.
I
Yeah,
have
go
a
ahead.
question.
Sure.
In the last diagram, are both the cardinality and the participation optional? Like the
Wait,
one.
is this one? Which one?
No. The next slide. Yeah.
This one.
In the last diagram, both the
This one?
participation and that
Okay.
one. Are both participation and cardinality optional?
You know what? It's missing one. I think the author just indicated this is the participation.
Okay.
So usually you have two. Okay, so hold on. This is a great question. This is not complete. So let's go back to see whether we have another good example. Not here. Okay, so this is just participation.
Okay.
Okay, great observation. Yeah. You see, for all other ends, there are two symbols, right? But for this end, there's just one. I think one is left out by the author. Any other question? Okay, so I will continue on with next subject. After the entity relationship modeling had been used in the industry a few years, quite a few years after it had been in services, the academic community and the industry found some deficiencies with the original entity relationship modeling. Therefore, enhanced entity relationship modeling was invented and deployed to improve the original entity relationship modeling. Going from the original entity relationship modeling to enhanced, there's just one thing, okay? One thing we need to be concerned with. That's the design and implementation of specialization and generalization. We use generalization to come up with supertype. Supertype can also be called superclass, depending on the authors. So both are commonly used. We use specialization to come up with subtype. Subtype can also be called subclass. We are going to look at examples so we can better understand what we are talking about here. I also took this from your Connolly and Beck book. This is a design based on the original entity relationship modeling. So it has information about employees, right? In any company, there are many types of employees. And with this design, it tries to be all inclusive. So we have all possible attributes that we will ever need for any type of employees. So you look at the attributes. We have some common attributes, attributes which are common to all types of employees, such as staff number, right? Name, position, and the salary. We also have attributes which are unique to each type of employees. For example, for managers, we want to know the manager start date and that we give managers a bonus. For salespeople, we want to know the sales territory of a salesperson, and we also give a salesperson car allowance. For secretaries, we care about the typing. Okay, you must type 60, 50, whatever number of words per minute. So look at this design again, which is based on the original entity relationship modeling. We can tell this design does not provide enough semantic meaning, right? not very clear. Also, space is wasted. That's what prompted the academic community and the industry to invent and deploy the enhanced entity relationship modeling to improve the original one. I took this from your book. So this is an enhanced entity relationship diagram. You can see we have a super type, staff, and then 3 subtypes, manager, salesperson, and secretary, right? And this is UML. With UML, we use this triangle, okay, triangle and a line to indicate specialization and generalization. So keep in mind, we use generalization to come up with a super type, and a super type has attributes common to all types of employees, right? So let's just think about English, not the database jargon. So generalization, right? We generalize to come up with attributes which are common to all types of employees. So those are staff number, name, position, salary. So we have the super type here, and then we use specialization. Again, think about English, specialized, right? Specific, right? So we use specialization to come up with subtypes, 3 subtypes. In the manager subtype, we have attributes which are unique to managers, and so on and so forth. Okay. Again, a super type, the symbol, 3 subtypes. We still have business rules that we want to enforce, right? So business rules, business requirements, those are always our #1 priority. We just learned we use multiplicity to implement and to enforce business rules. Multiplicity, right? Think about that in your mind, in your head. And with multiplicity, there are 2 components, cardinality, participation, right? Keep this in your mind. So let's see how we specify multiplicity for EERD. We put it here. So participation is optional. Then for cardinality, we use AND. You are wondering what AND is, right? We've never seen this before. So I put some notes here. With EERD, we use disjoint. Okay, we use disjoint to specify cardinality. Disjoint is just sort of a field, sort of a designator, right? There could be one of the several values. If disjoint is all, then a tuple in the super type can belong in just one of the subtype. A tuple in a super type can belong in just one of the subtypes. Okay, if it's all. If disjoint is AND, overlapping, or non-disjoint, then a tuple in the super type can belong in more than one subtype. So we put AND here. So in our example, that's AND, right? AND, overlapping, non-disjoint, they're all the same. One example is a staff member could be a salesperson, could be also a manager, right? So that's AND. An example of OR is a staff member is just a secretary. Okay. Take another look at this slide. Make sure you understand it, and this will make your reading assignment a lot more manageable. Okay, continue on. We have one example based on the closed food. So we use this circle to indicate specialization, generalization, supertype, subtype. Okay. And another thing, which is very important, I want everyone to keep in mind is when we implement enhanced modeling, we usually implement that in part of our overall ERD, not the complete entire ERD, okay? You look at this example, we have one supertype, 3 subtypes. We also have a regular entity, the entity that might be included in the original entity relationship diagram branch. Here, right? Supertype, subtypes, and then we have other regular entities. Any question? So I think we are clear on outpatient and resident patient, right? An outpatient goes to the hospital and then get some services and then go home the same day. A resident patient would spend at least one night at the hospital and will need to get a bed. And everyone has a responsible physician. Yeah, what's the question?
Professor, in the first diagram, like the last slide.
This one?
Yeah.
Or this which one? This one?
Yeah, that one. The subclasses is the super type, right? And then the salesperson are the subtype. Sales personnel, manager, and secretary are subtype, and later on the staff and branch. Or am I getting this wrong?
So this is the super type. These 3 are subtypes.
So, so the arrows, like they are pointing in the like.
Oh, this you are talking about this one, right?
Yeah.
Or this. Which arrow?
The big triangle one.
Try this one. Yeah, this points to the super type.
Okay, thanks.